Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give two examples related to the use of normal distribution and the standard normal distribution. And this is just a recap. If you have a random variable x, and x here is a normal random variable, therefore the distribution of x can be described using this equation. And x here takes values from greater than negative infinity and less than infinity, so it takes all the real values. And if let's say you want to describe x in terms of using graphs, so you want to look at the distribution of x using graphs, then the graphs will look like this depending on the parameters of mu and sigma squared. So basically the graph is going to have a bell shape outlook, and it's going to be symmetric. At this position here will be the position of the mean, and the spread of the graph is related to the variance. So for example here, when the variance is small, then the spread of the graph is this much, okay, compared to when the graph is like, for example, 5, the variance is 5, then you can see that the values here are spread out even more, okay. Right, so that is the distribution of x. Now if x is a standard normal random variable, therefore this is the equation, this is the probability density that described a standard normal random variable. And for more clarity, we change the use of x to z. So z here is a random variable that represents the standard normal situation, okay. Z here is a standard normal random variable. So these are the equations related to normal random variable and standard normal random variable. So how do we get this? Is because we set the value of mu equals to 0 and the value of variance equals to 1. Therefore we get this probability density given here. In terms of practice, x can be converted to z if you use this formula. So any values of x can be converted to z using this formula, which is x minus mu over sigma. So mu here is the population mean and sigma here is the standard deviation. And we're going to use this a lot when you try to solve probability questions related to normal distribution, okay. Now this is an example here. We have the mean number of hours an American worker spends on the computer is 3.1. Sorry. Okay, so 3.1 hours per work day. Assume the standard deviation is 0.5 hour. Find the percentage of workers who spend less than 3.8 hours on the computer. Assume the variable is normally distributed. So what is our variable here? Our variable is this one, the number of hours an American worker spends on the computer. Okay, so here is x. X is the number of hours spent on the computer. And of course, you can imagine the value of it is going to be different from one person to another, yeah. And it says here that the mean number of hours, that means the mean of x, is 3.1. And x here has a normal distribution, so we can write down in terms of this mathematical notation, x has a normal distribution with mean, mu, and variance a certain value. And we know that from this information here, the mean is 3.1. So mean is 3.1, And it says here the standard deviation of x here is 0.5 hour, which means it is going to be 0.5 and you square it, okay? Then you get the variance. Here is sigma squared, here is variance. So if standard deviation is 0.5, so the position here represents variance, therefore 0.5 has to be squared, right? Okay, so this is the information given in the example here. Next, the question is asking you to find percentage of workers who spend less than 3.8 hours. So what's the answer to that? And it can be mathematically translated as percentage is this one, spend less than 3.8. So here we are talking about the number of hours they spend on the computers, which is percentage of x, less than 3.8. So that's how you can translate the long sentence into some mathematical statement, and we're not done yet. What is the result of that? And percentage here can be found if you find the probability that x takes a value of less than 3.8. And we have learned in the earlier chapter of continuous probability distribution, for example. If you want to find the probability x less than 3.8, what you should do is you should integrate, right, a function which is fx, a function, the probability density of x. 3.8 is the upper limit, and it's going to be the lower limit here is some value, and here x is a normal random variable, and therefore by the actual process you should be integrating this complicated looking function where you're going to replace mu with the value of 3.1 into the equation, and sigma is 0.5. So this is what you're supposed to do. Actually, you should integrate this function from what's the lower limit. The lower limit is going to be negative infinity until 3.8. By right, this is what you are supposed to do, and it's going to be cumbersome and difficult, but that's why we created, not we, I mean other people created what we call the standard normal distribution table, so we don't have to do that process anymore. Okay, so the standard normal distribution table, for example this one, is a specific distribution where mu is 0 and sigma squared is 1. And here if you look at the graph here, it the result that you see inside the table here is the result of integrating a function from negative infinity to a certain value. Okay, so that you don't have to do the integral process anymore, because like I said, it's going to be a bit cumbersome. So they come up with a table where the values here are the results of integration process. Okay, similar idea to what you have seen in the previous chapter related to the continuous distribution. Okay, right, so by right this is what we are supposed to do, but we don't have to do it because we already have a table, a z table, that gives you the results of the integration inside that table. So that's why in order to use the table, you need to convert a normal random variable, so x here is a normal random variable, to z random variable in order to use the formula. Okay, so that's what we're going to do. Okay, we are going to convert that. Excuse me. Alright, so in order to convert that, we are going to apply the formula here. That means x here you need to subtract that with mu over sigma. Therefore, on this side also you have to subtract with mu over sigma. Yes, so that's the process. And x minus mu over sigma is z. So we can just replace that with z. 3.8 minus mu, so this is 3.8 minus 3.1 over sigma is 0.5. And you calculate this, you will get probability z less than 1.4. And again, according to the theory that you have learned in the earlier chapters, if you want to find the probability of z less than or equal to 1.4, or sorry, in this case less than 1.4, what you need to do is you need to integrate the probability density of z with respect to z and 1.4 until the lower limit, because this is the upper limit. And what is the probability density of z? If z here, now the standard normal random variable, the probability is density is this one. So you, by right, you have to integrate this function here. And again, I told you just now, we don't have to do this process because the result of the integration has already been given here. So when you talk about this graph here, it tells you the result of integration from some value of x until the lower value fz dz. So in other words, it tells you the probability of getting x, or in this case, they still use x for the standard normal random variable, it's okay. Well, here is the probability of x less than or equal to x, which is the same thing as finding the probability of x less than small x, okay? Right. In this part here, this is also the standard normal distribution, but here the result in the table here is related to this integral process, where of course you have to integrate the probability density of z, the standard normal, the probability density of the standard normal random variable, except that the difference here is related to the limits. The limit here is between some value of z until 0. So you're talking about this specific area from some value of z until 0. So here the lower limit is 0 for this table. On the other hand, here the lower limit is negative infinity, which is this one here. It goes on in this direction, okay? So that's the difference between the two tables. Now again, we don't have to do integration anymore because it has already been done and the results have been tabulated in the table, so we can use it straight away. So when you talk about probability z less than 1.4, you're talking about, well, this is our z distribution. It looks like this. The middle point must be 0, so 1.4 must be on this side. So when you talk about less than 1.4, you're talking about this area. And you're going to look at the table that gives you this area. You can see that for this table, it gives you one area from this point to this side. So we know that we can use this table instead of this one, because this one here, it doesn't give you a direct answer. If you look at the table, you need to do some adjustment or modification, and we will look at it later on, okay? So if you use this table, you can see it has similar shape, shaded area to what we are looking for, z less than 1.4. So we can just read straight away from the table. This is the value of z on this side, 1.4. So the result here is 0.9192. So this is the area, or the result of the integral. Okay, so this is the probability, the area. So the result is, this one is equal to 0.9192. okay. Well, on the other hand, if you want to use the second table, so this is the second table, notice that in this second table, you will see that the result inside here is related to just this part, from 0 to some positive value. So our question is originally like this, 1.4. Okay, so if you read from the table the value of 1.4, it will give you the result here is 0.4192, and what it means is they just give you the area from 1.4 to 0, so which is 0.4192. So if you want to use the table in order to get the correct answer, which is this area, therefore probability z less than 1.4 must be this value, 0.4192, plus this area. So this area is equal to 0.5, okay, because it's symmetric, it's half of the other area. So this area here is 0.5. Therefore the answer can be obtained if you add up 0.4192, which is this part, with 0.5, and the answer is going to be 0.9192. Okay, right, let's look at the next example here. Well, for a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. So if the mean systolic blood pressure is 120, so the mean of systolic blood pressure, the standard deviation is 8. Find the upper and lower readings that would qualify people to participate in the study. Assume that readings of blood pressure has a normal distribution. Oops. Okay, so in this example here, it says, well, mean of systolic blood pressure is 120. Standard deviation of blood pressure is 8. So you can see that blood pressure has a normal distribution, the readings here, and therefore we know that the blood pressure reading is x. So here we're talking about x. The mean of x is 120, the standard deviation of x is 8, and x here has a normal distribution. So I'm just going to say that x here represents the readings of blood pressure, right? And x has a normal distribution with mean mu and variance sigma squared. And based on this, we can substitute what is mu. Mu is 120. Variance is, you have to square this value because this is standard deviation. So variance is 8 squared. Okay. Right. Now, the question is asking you to find the upper and lower readings that would qualify people to participate in the study. So that means the lower value of x and the upper value of x. Now, in order to answer this question, let us try to visualize how the distribution of x is. Since x here is a normal distribution, therefore, if I sketch the graph, it will look like this. It will look like it has a bell-shaped graph. Okay, and we know that the center point here is going to be at point mu, which is 120. That is what's going on here. And we want to know what's the upper and lower readings. So what is the upper value and lower value of x, such that it will qualify people to participate in the study. And the researcher here wishes to select people in the middle 60%. That means this is the middle, and we want it 60% of the population, the middle 60% of the population, which means it is interested to find this part because it has to be in the middle. That means from this point to this point, it's going to be 30%. And then from this point, and then from this point to this point, it's going to be another 30%. So altogether is 60%. So we want to know what is the XU, the upper reading. And on this part here, we want to know what is XL, the lower reading. Okay, so basically, they want to know what's the value here, XU and XL. So this is the distribution of X. And again, I've told you many times that we're so lucky to have a standard normal distribution so that we don't have to do the integral process, that complicated integral process. And whenever you want to solve probability questions related to normal distribution, we can make use of the Z table. And that's what we're going to do. In order to solve this probability question, we need to be able to convert any normal random variable into the standard normal. So how does X get converted into standard normal distribution? So here is X. Now we're going to look at how that can be converted. So from X, we want to go to Z. And the conversion from X to Z, use this formula. Z is equal to X minus mu over sigma. So if X is 120, so here X is 120. So if X is 120, Z will become 120 minus what is mu? Mu is also 120 over sigma is 8. So the value of Z when X is 120 is 0. So this value here from 120, it will be transformed into the value of Z equals to 0 at this center point as well. Well, based on that, maybe what you can do is you want to find what is XU. So XU here will be translated into a certain value on Z. I'm just going to call it ZU, okay? So again, what is ZU? According to the formula, ZU must be equal to XU, which we don't know, minus 120 over 8. Now, can you find the value of ZU? Yes, you can, because I know the area from 0 to ZU. I know this area, right? And the area is 0.3 or 30%. Okay, so the area is 0.3. And I can use this table because this table has the same shaded area as what we would like to find. So the table here gives the shaded area in between 0 and some value. I would like to find some value and 0, and I know the area here. So I can just go and find where is 0.3 inside this table. Okay, so I need to go and find where is 0.3. Well, 0.3 will be somewhere between this value and this value. And I will choose which one is the closest to what we're looking for, which is area 0.3. So this area here, I want to find the area of 0.3. And I can see that this value is closer to 0.3. So the Z here is going to be 0.84. So the position here is going to be 0.84, right? Therefore, I know that based on the table here, this one is 0.84. And I'm going to use this result and apply on this formula right here. So 0.84 is equal to XU minus 120 over 8. Therefore, based on this, you should be able to get XU must be equal to 0.84 times 8 plus 120, which is 126.72. Okay, right. In a similar manner, what you can do is you can also find what's the value of XL. We know that if XL gets converted into Z value, the value is going to be something, I don't know, we just call it ZL. Can I find what is ZL? Yes, I can. Let's say I want to use the other table, yeah? I want to use this table. What this table does is it gives you the result or the area from one point to another, okay? And if I want to use that result or that table, or maybe I don't have to use that table at all, because you see, let's not complicate the process. Well, you see, ZU is 0.84, and because it is symmetric, right, this is 30%, and from this point to this point is also 30%. Therefore, ZL is going to be negative 0.84. It is symmetric. And I can use again this formula here to get what's the value of this one. So ZL is equal to XL minus 120 over 8, and ZL is negative 0.84. I'm just going to write down that. Okay, therefore XL is going to be negative 0.84 times 8 plus 120, and XL is 113.28. Therefore, these are the answers. These are the upper and lower readings. That means people with the readings of blood pressure between 113.28 and 126.72 will be included in the study. Okay, all right, I think that's all for now. Thank you very much for watching.